All right, so this is a worked out explanation for question 20, A and B on my practice exam. So the question asks, for each of the following, determine the concentration of hydronium and the concentration of hydroxide, and whether the solution is acid, basic, or neutral. So part A says a 0.015 molar solution of HCl. So what we can take away from this is that HCl is a strong acid, which we should have memorized. So acid is going to be, it's going to give us the concentration of this. Again, big M is moles over liters, and so we're given its big M, so we can assume that liters equals 1 and that 0.015 equals moles. And so now we have the concentration of acid from this. So we can use the equation H3O plus times OH minus equals 1 times 10 to the negative 14th. Oh, that's a bad 1, 4. And we can plug in 0.015 here, solve for x here. Alright, so when I solve for x, I get 6.7 times 10 to the negative 13th molar. So here's our concentration of OH. Here's our concentration of H3O plus. And now we need to determine if the solution is acidic, basic, or neutral. So we can just see which has the higher concentration. We could plug it into the pH formula, but we could just look at this and know that 0.015 is a lot bigger than 6.7 times 10 to the 13th, so that this must be an acidic solution. Alright, number B here is like the hardest question on my practice exam, so if you missed it or are very, very confused, don't feel bad. So calcium hydroxide, it's got that hydroxide ion in it, so this is going to be our base. So we're given that concentration, kind of. So we're given it in grams. So we need to get to moles. Grams, moles. Let's find the molar mass here. Molar mass of calcium hydroxide is 74. Gonna run out of room. 74.093 grams. When we work that out on the calculator, we have 0.02159 moles. So, and I apologize, I realized I told you wrong up here. We didn't need to put it into moles. We could have, this is the concentration in big M, so we could have literally just said strong acid and plugged it in there like we did. So here, now we're in moles, but we need to get to big M. We got the moles, we're also given a volume. Of course, now that's not in liters, so if we just real quick bunny hopped, 100 milliliters is 0.1 liter. So let's real quick put this in M here. So I got, and I'm going to round to, let's say 2 sig, no, we'll do 3. All right. 0.216 is going to be the concentration of our base. But there's one more step. Oh, okay. So this is the concentration of big M, the base, OH. But we want the concentration of OH not to the second, but since this was given in grams of calcium OH2, this is for the concentration, like basically times 2. The concentration of OH times 2, since we have that subscript 2. So we need to divide that concentration by 2 to get OH by itself, not OH2. So when I divide this number by 2, I get 0.01. And again, I'm going to round to 3 sig figs. 0.0108 big M. All right. So that's the catch, okay? That's, like I said, probably the hardest question, and we're not even done with it. So I'm going to erase this upper part to give myself some more room. Okay, so we got the concentration of OH. We still need to get the concentration of H3O plus, or H plus to be simple, and figure out if the solution is acidic or basic. So again, we can use this formula, and I'm going to abbreviate H3O plus as H plus. We already have this, and so now we just need to solve for our X here. I'm going to real quick plug this into my calculator. So I get H as, and again rounding to 2 sig figs, 9.26 times 10 to the negative 13th big M. And again, this is the concentration of H plus. So now when we compare the two, this is much larger than some number to the negative 13th, so this is a basic solution. Here, if you couldn't see what I was writing on the side there.